talking about storms, we've talked a little bit about snowstorms alongside um, thunderstorms, but we really need to talk about tornadoes. And tornadoes are most common in North America, but they happen on every continent with the exception of Antarctica. So, although common to North America, um, definitely not uncommon to other locations. Now, the most prevalent location for tornadoes, as many of you probably know, is Tornado Alley, which extends from Texas up through Kansas and Oklahoma into parts of Iowa. But what we have seen over the last several decades is that Tornado Alley has expanded, and people are considering parts of Colorado and parts of Ohio even as Tornado Alley. But we're also seeing the genesis of what meteorologists are calling Dixie Alley, where we're seeing much more tornado action in parts of Louisiana, parts of Mississippi than ever before. Now, Mississippi did get tornadoes in the past when we really only were talking about Tornado Alley, but we're seeing these clusters of tornadoes through these other states, again, particularly Louisiana. And they do come in clusters, and they're often early season tornadoes. Now, Tornado Alley has a lot of seasonality to it, and what ends up happening, if we were to go back to this slide set that is our winter condition, we've got this maritime tropical air mass coming out of the Gulf, which is really, really warm, with these continental Pacific air mass sitting much lower. So early in the season, our first tornadoes start to occur in Texas and Mississippi, a little bit of Alabama. So we're coming in through here with these tornadoes, and so we've got usually March, April tornadoes here as the maritime tropical is pushing north and the continental Pacific is retracting north. That front that's creating the difference between the two, which is creating the interaction zone, the frontal zone, is going to then generate more tornadoes as it retracts. So we've got March, April, May, June, and then June, July up here is where these storms are starting to occur with seasonal changes happening. While I've got this slide up, although this is really where we're getting storms over the last several decades, we've seen many more storms occurring in the mountainous west and throughout parts of Appalachia, to include clusters in Canada. So growing up in Canada, I had a physics teacher that said, I was in a tornado in southern Alberta, and we're like, what? You are crazy. But in 1985, a Category 5 tornado hit way up here, and now that is not uncommon. Category 5s across this part of Canada is a seasonal event every summer now. So this is a function of two things. It's got to be warm enough to generate these storms. So the summers here are getting hot enough, but in places that are dry, where we shouldn't be getting storms in the past, here and part of the Great Desert, which is southern Alberta through southern Saskatchewan and parts of Manitoba, we've moved water, we've created irrigation systems, we've impounded and created lakes, which now are sources of evaporated water, to then create these localized storms to create tornadoes. So there are changes that are occurring that are creating tornadoes. And every year students tell me, oh yeah, I was in a tornado. It was, near Campbell, or it was, just south of where I live in Stark County. So Ohio is seeing a lot more tornadoes, or at least a lot more funnel clouds as well. So with our tornadoes, they are generally considered to be a May-June tornado season. But tornado season is becoming much larger, and places like Texas are getting tornadoes in January, and we're getting tornadoes across the continent well into September. So not only are we getting more locations of tornadoes and creating new tornado alleys, but the season's getting much longer as well. So that's a really good head scratcher. Why is this occurring? So just like our typhoons and our hurricanes and our snowstorms and thunderstorms, these are the production of uplifting air and latent heat. And really, they are the function of thunderstorms or frontal lifting systems occurring, but they are really large in size and they're generated out of something called a supercell. So these big supercells occur in the past. Around 2,000 supercells have been acknowledged to generate across the continent every summer. But now we're starting to see more supercells than that occurring. And so if we're going to generate more supercells, we'll generate more tornadoes. Typically, 30% of all supercells generated tornadoes. So if we had 1,000 supercells, that means we have about 30 tornadoes, right? So we're just going to amplify that. Now, it's important to say that a tornado is only a tornado when it hits the surface of the earth. And you know that because it starts to kick up a lot of debris. It starts to look a little green, if you will. But before it hits the surface of the earth, it's considered a funnel cloud. So a lot of the storm cells that people have been seeing in Ohio have been funnel clouds. They haven't actually touched the surface of the earth, but I would argue that it's terrifying enough to watch a funnel cloud come down. If you're getting a funnel cloud, you're still getting really hazardous weather, and it's still an incredible problem. So with that, just to appreciate how some of these storms generate, is that we get this horizontal rolling across the landscape, and that horizontal rolling meets air which is starting to form from atmospheric lifting. So we're pushing that air vertically up. And so we get this vertical rotation along with this horizontal rotation that initiates a spin in this storm. And it's the spin which can produces something called a mesocyclone, meso meaning middle, our middle scale. Now, so macro would be our hurricane, meso is our tornado, and like a dust devil would be a micro cyclone. So we get this mesocycle tornadic action that occurs. So that's storms and atmospheric disturbance for everybody. And contact me if you want to talk more about any of this stuff, if you want some clarification, or if you just want to talk about storm stories.